Welcome back. Let's continue our conversation about reusable building blocks and talk about object oriented programming, or OOP. As programmers, we love acronyms, so that's another one of those. But it means object oriented programming. And what it means is that you define your reusable building blocks, the stuff in your program, in your code that you want to be able to reuse. And it's basically split into two parts, and that's also two words, two things that you need to understand. The first one is the word class, and the other one is the word object. And these are two different things, and we need both of them to understand object-oriented programming. So let me begin by talking about what a class is. CLASS, like class in school. But here it means basically a definition or a blueprint for a block of code that you want to be able to reuse. So what it means is it's got a name, this class, and it's got a couple of variables. It's got a couple of data types that you can store then in objects of that class later on. But first of all, it's just a blueprint. You can think of it like, I don't know, an index card, right? And with the index card, you've got a left side and a right side. Maybe you've got a vertical line there. And on the left side, you define basically the fields, the types of data that you want to store on that index card. So let's make a concrete example. Let's say we want to track patients, and we want to prepare these index cards for our patients of a doctor's office maybe. And so what do we want to track? What do we want to know? What do we need in our blueprint, in our class definition? Let's say we want to know the patient's name and the patient's weight. Right? It's a very, very simple example. It's a very simple doctor's office that just track two kinds of data for each patient, just the name and the current weight. And the class now defines that you've got this class patient, it has a name, and we have a member variable, we have a property for objects that's for certain patients that we can use. And for each of them, we store the name, which is going to be a text variable, right? A string variable, and the weight, which is some kind of numeric variable. And that's in our class definition. So you could say it's like a collection of variables, like the weight variable and the name variable, but it doesn't really have a specific value yet. It's not like that we set the name to John or the weight to 200. It's just our blueprint. It's like preparing these index cards. And on all these index cards and these empty index cards that are in front of us, we just write name and weight there, but we leave everything else empty. It's just really the blueprint. And one important thing is that you can also have a function, a certain interactive functionality, a piece of code that evaluates something as part of that class definition. And to keep with the patient's example and to keep it very, very simple, let's say that this functionality is a function that is called is overweight, meaning is the patient overweight? And it just returns true or false. It's one of these Boolean types, these binary types. You can just have a value of yes or no, or actually true or false. And when we call this method, then later on for a specific patient, it will return whether this patient is currently overweight or not, taking into account the weight variable there. Okay, so that's the class, that's the definition, that's the blueprint. We know that we've got a patient class, that's the class name. We've got a member variable for the name, which is a string variable, and the member variable for the weight, which is a numeric variable, and we've got a function called is overweight. So that's the class part. Now let's switch over to the object. An object is then a specific instance. It's like taking these index cards that you have prepared and now filling them out for a specific patient. For example, let's take our index card and we see that we have a name, a weight, and we can call the function is overweight. So let's fill out the name. Let's say the name is John. So that means we store for this specific object there for our index card that we hold in our hands, we store the value John for this patient's name here. And we store a weight of, let's say, 200. Whether that's kilograms or pounds, I leave that up to you. But we've got two values there: the name of being John and the weight being 200. And now we can call the function is overweight, and it would return true or false, depending on the logic. So with 200, John being 200 pounds or kilograms, doesn't really matter. That's still overweight in both scenarios. So let's assume that this overweight function will return true there. So that's one card there. It's one specific object that refers to that class definition, that blueprint of having a name, a weight, and this function is overweight. Let's say we have another patient there. We take another business card, another index card, and write the name Pam there, and the weight is 100. So is overweight is returning false, let's assume. However, this is overweight function will work, but it's just important that we know that we have not just member variables, property variables as part of our definition there, as our class definition of our blueprint, but also functions, code that we can call that then sort of takes into account the current values of the member variables that are being stored, of like the fields that we've written down on our index card. Okay, so that's the distinction between classes and objects. You define a class once, like we have defined this blueprint for this class patient once, and then we can create many objects that have all different values, like for John and Pam and 200 weight or 100 weight, and have their own methods that we can call, their own interactive functions there. And we can create as many objects as we want from this one single class, and they all refer to this single class definition, this single blueprint. They are all patients. They've got different names, they've got different weight, but they all have a weight and a name. And that's something that we know because we know in our class patient, this is defined as, well, we've got a name as a string variable and a weight as a numeric variable. Okay, so I hope that sort of sheds some light into this sometimes weird concept of object-oriented programming. The idea is really that we take objects from the real world, we define their common functionalities, their common attributes as variables and as functions. And then we've defined this as a class definition, and then we can create many different objects. Like assume you've got a class definition for a car. It could have a color variable, right? And it could have a current speed variable, and it could have a function of speeding up or braking, right? Reducing, making the speed slower. And that's the class definition. Then we can have different objects, different instances of cars, right? We can have a red car that's currently going 100 miles per second per hour. Per second would be a bit quick, I guess. And we've got a blue car instance with a speed of 0 that's currently standing still, and so on. Okay, so that's the distinction between objects and classes. So again, as your homework, I invite you to open your contact list app, for example, on your smartphone. And identify the classes there. Most probably you've got a class called contact, and that's made up of different fields that you can fill out for a specific contact, sorry. You've got a name, maybe split into first name, last name, middle name, maybe. So that's already 3 different variables that you can store for a contact. You've got probably a phone number, an email address, and so on. Okay, so try to identify what's the class there, what are the properties that are defined as a blueprint. And then for specific contacts, for specific names in your contact list, what are the values there set to the different names and email addresses and telephone numbers? But maybe you've got other classes there as well in your contact list. Maybe you've got a class called group. Maybe you can group different contacts together. So try to dive into that. Use something that you use every day, like your smartphone, and an app that you use every day, and try to identify, okay, what's the different classes there that are in play here? How are they defined? What kind of properties do they have? That's usually easier to identify. Maybe you've got some methods there that you can identify as well. For a contact, it could be like delete contact. right? Or maybe share your contact with somebody else. Send it over Messenger, right? Your contact details of a specific contact there. Okay, so do this on your contact list. Try to identify classes and objects, and talk to you soon.